Hello and welcome back to Math 30-1. In today's lesson, we're going to look at how we could use exponential and logarithmic functions to help us in finance, okay? So let's take a look at our first question. All right, we have Millie invests $2,350 at 7% per year for 6 months. So this is just simple interest. Now, calculate how much she makes after 6 months. Well, she wants to know her interest, she invests $2,350 at 0.07%. She only makes that. After 6 months, that's half a year, and it's per year. So we end up doing this, I'm going to end up getting $82.25. And I multiply that out. Now it says, what is the value of Millie's investment? Well, this is how much she makes, and we have to add that to that, how much she already has. So she's going to end up having $2,350 plus 82.25 is going to give me $2,432.25. Okay? And there we go. That's all there is to that. So it's not that bad. Now we're going to get into compound interest. So before you start that, I strongly advise that you read over this part and go over to these exploring compound interest on the next few pages. Okay? Right here, and see what their graphs look like and why we do compound interest the way we do. So here we go. Let's take a look at class example number 2. It says $1,000 is invested for 5 years at an annual interest rate of 6%. Complete the table to calculate the final value of the investment if interest is compounded according to the final period. So let's look at this now. We have compounded annually, semi-annually, quarterly, and monthly. All right? Now, if I was to do each of these, we'll just I'll first do all these, set up the formulas, and see if you can figure out what's happening, okay? So first of all, we have annually. Well, how many times is that? That's 1 time per year. So the total number of compounding periods is going to be, I'm going to have 1 period, or 5, because it's over 5 years. 1 multiplied by 5 is equal to 5. So the interest rate per compounding period, well, it's going to be 6%. So my formula here is going to be A is equal to, well, we have 100,000, or 1,000 is what we're starting with, multiplied by 1.06 to the power of 6. Okay? Now, let's take a look at semi-annual. That is over 2 years. There's 2 1 year. There's 2 compounding periods in semi-annual. Okay? Well, what ends up happening here is we have 2 compounding periods, because 2 times per year, we multiply that by 5, it's going to give me 10. Now, how much are we going to be interest? Because it's only 6% per year, but we're doing a semi-annual, so it's happening twice a year. So that's 6 over 2, which gives me a 3%. So that is only 3%. So my formula is going to be 1,000 multiplied by 1.03 to the power of 10. Oops, this should have been 5 up here. I don't know why I put 6. That should have been 5 looking up. Okay? Let's take a look at the next one, quarterly. So how many compounding periods are there quarterly? Well, there's going to be 4. So we look at this, that's going to be 4 multiplied by 5, which will give me 20. Okay? Because we have 4 times a year, 5 years, that gives me 20. Now it's 6% per year, and each time we would compound it 4 times per year. We can't go over 6, so we divide that by 4, which gives me 1.5%. So we have 1,000 multiplied by 1.00, or 1.0, not 00, 0.15, 100%, and we have to add 1.5% every time to the power of 20. Okay? We go 100% plus the interest, which is 6%, because every time we're going 100% and then 6% interest. So now the monthly is, there's 12, so that's 12 multiplied by 5, which is 60. We have 60 times we're compounding it. And we have 6 all over 12, which gives me 0.5%. So we have 1,000 multiplied by 1.005, all to the power of 60. Now, I want you to look at this without calculating first, and which one do you think is going to be more value? If we compound annually, semi-annually, quarterly, or monthly, and why? Okay, I want you to pause it, look at this, look at these equations, and think if you could think of why one would be more valuable than the other. And then resume once you wrote down which one you think is going to be the most valuable. Okay, so if I plug this into my calculator, for this one here, I'm going to end up getting $1,338.23. This next one here, for semi-annually, I'm going to get $1,343.92. My next one here, if I plug into the calculator, I'm going to get 1,346.86. And my last one, if I plug in the calculator, is going to be 1,348.85. Now, if I look at that, this last one, monthly, was the most expensive. Now, I want you to think as to why. Well, think of what's happening. We're going 6%, yeah, total in the year, but each time we are multiplying by 5%. So it's building on each other. We multiply by 0.05, which is, or sorry, not 5%, 0.5%. So 0.5% each month. So he's increasing each month, and so the 6% is compounded, so it grows faster, okay? So that's why that one is a little bit better. Here we go. Let's take a look at question number 3. It says, $7,000 invested in a 6-year GIC, compounded quarterly at a rate of 5% per annum. Determine the value of the investment at the end of the term. So, my amount, we want to figure out my investment at the end. That's what we're figuring out. My principal is $7,000. Okay? My interest is, well, it's 5% per year and is compounded quarterly. So 5 divided by 4, because it's compounded quarterly, which is 1.25%. Now my next part here says my number of compounding periods. Well, that's going to be 6 years. We have 6 years, and we're multiplying that by 4, which will give me 24. So let's plug this into my formula. I'm going to end up getting A is equal to 7,000 multiplied by, well, we have 100%, and then plus, we're always increasing by 1.25, all to the power of 24. So what's that going to end up giving me? This will give me $9,431.36. So that's how much money he'll have at the end, which is a pretty good amount of change and a good investment. Okay, let's take a look at example number 4. Now it says Christina invested $2,500, so $2,500 that she invested, for 4 years, compounded semi-annually, and received that much. Oh, we have this. So it's 843.26. 4 years semi-annually, well, that's going to be 4 multiplied by 2 is equal to 8. And we want to determine the annual interest rate. Well, we want to know the annual interest rate. Well, that's going to be I divided by 2 when we're putting in our equation, because it's semi-annual. So let's put this into my equation. All right, so we have 843. Oh, sorry. That's how much she received. So her original, we have to add 2,500 to this to figure out how much does she have overall in the end, which will end up giving us a total of $3,343.26. Okay? So now let's put this out here. So we have 3,343.26 is equal to, well, my principal is 2,500, and then we want to multiply that by my interest, which is 100%, plus whatever my interest is divided by 2, right? My annual interest divided by 2 is going to give me to the power of 8. Okay, so we want that all 8 times because we're compounding it 8 times. Now, let's try and solve for this. So my first step is I'm going to divide everything we want to isolate from my variable, divide everything by 2,500. So I get 3.26 divided by 2,500 is equal to 1 plus 8. Now I'm going to have to take the 8th root of everything. Okay? So we end up getting, I'll just put an 8 there. You could go to the power of 1 over 8. 3343.26 divided by 2,500 is equal to 1 plus I over 2. So I'm going to take away 1 from both sides. Take away 1. Okay? So I end up getting now, if I square root this, I'm going to get 1.07. Subtract 1 is equal to I over 2. So I'm going to get 0.37 is equal to my interest divided by 2, my yearly interest. Multiply both sides by 2. I get 0.74 is equal to my yearly interest. And that's it. All right, let's take a look at example number 5. It says Barbara invests $8,000 in an account which pays compound interest of 6% per annum. So she invests $8,000. Okay, and it's 6% per annum compounded monthly. Oh, so that's 6 divided by 12, which is 0.5%. Okay, how long would it take in years and months for her investment to double in value? Okay, so this has to be 1,600. Okay, 1,600, or 16,000. And we want to know my n. Okay, so this is an exponent trying to figure out. So let's put in our formula. Oops, 16000 is equal to 8. 0.5 to the n. Well, I could simplify this. I'm going to divide both these by 8,000, so I get 2 is equal to 1.005 to the n. Now I look at this, what's my problem? I can't make these same bases. So what must I do? I must log it. And I'm just going to use, I could either log both sides or use my log identity. I'm going to just log both sides here to go over that one. So we're going to go log 2 is equal to log 1.05, and that allows me to bring down the n. So n is equal to log 2 divided by log 1.05. I plug that into my calculator, and I'm going to end up getting a total of 139. Okay? So there's 139 compounding periods, so I'm going to go 139 divided by 12, which will end up giving me 11 years and 7 months. Okay, so it's 11, remainder 7. Okay, so we just kind of have to go that way. All right? So it's 11 years and 7 months it will take for them to double. Borrowing money. All right, so now we're going to look at borrowing money. So let's take a look. Andrea borrows $7,500 from her parents to buy a new car. Her parents charge her interest at 4% per annum, compounded quarterly. When she pays off the loan, she has to pay $7,085 interest. What was the length of her loan? Okay, so we're going to start this off again. So she makes that much. So let's take a look here. We're going to go A, P, I, interest, and N. Get all my values there. So this is going to be 7,500 plus 785, which will end up giving me 8,285. Now we want to know the principal is 7,500. Okay, 4% compounded quarterly, so that's 4 divided by 4, which is 1%. And number of compounding periods? So what was the length of the loan? It's going to be n multiplied by 4. So it's going to be 4n. So what was the length of the loan? Because we always multiply it by the amount of compounding periods. So let's put this into my formula. Okay, so I'm going to end up getting 828, I believe. 8285 is equal to 7500, and we multiply that by 1.01, all to the power of 4n. Okay? Because remember, it's compounded we have to multiply this by 4 to get that n, and then go that way. So let's try and solve for this. So first of all, we want to isolate the variable best we can. So I'm going to have 8285 divided by 7,500, 8,285, which is 1.01 to the power of 4n. Okay, now, I am going to maybe log both sides, and that's what I will do. I'm going to log both sides to make them equal. So I'm going to end up getting log all right, and we have 4n now down there. Okay, now I'm going to divide both sides by log 1.01, so I have 4n is equal to log 8285 divided by log 1.01. And I have to divide all this by 4. Whatever that answer is, I'm going to divide it by 4. So I plug that into my calculator, and I'm going to end up getting a total of we have a total of 2.5 years. 2.5 years. That's it. Okay? Because we end up getting 10 quarters. This here ends up being equal to around 10, and we divide it by 4, which is around 2.5 years. Okay? And that's everything. So hopefully you understood this. If you have any questions over this, don't be afraid to ask, as I'll help you out with it tomorrow as we work on all these questions together. All right, see you tomorrow.